Okay, this is your video explanation for chapter 6.5 on dividing fractions. What was the first question? What was the first question I didn't do? 3/5 divided by 9/10. So your first question is 3/5 divided by 9/10. And this will be the only one I do a video for because the other ones I've already done. So it says solve this using common denominators. And what we have to do is just explore this idea of what is an exact division question, except in using 3/5 we use a denominator in which both fractions share. So if I think this question as having denominators of 10, 3/5 and 6/10 are the same fraction. There's no difference in value. They're both decimal 6. They're both 60% of something. They both represent decimal 6. So both of those equations, or both those expressions, are the same. If I then say, well, if I have a division of two fractions, the algorithm is to simply divide the numerators, just like multiply the numerators is, and divide the denominators. So once I have my equivalent statement, I can divide the numerators to get 6 divided by 9. I can divide my denominators to get 10 divided by 10. But I'm not going to simplify the numerator yet. What I am going to do is simplify the denominator. And when I divide 10 by 10, I get 1. And what we've learned from our experience is that denominators of 1 are insignificant. So as a result, I can simply think of this whole thing here as being this. And 6 divided by 9 as a fraction is the same thing as 6 divided by 9 as a fraction, or 6 over 9, which in lowest terms is 2/3. So our answer to this question using common denominators is 2/3. A lot of people get confused right here at this step because once they get to common denominators, they forget that the algorithm for division or multiplication is to divide the numerators and divide the denominators to get an answer. If we didn't find common denominators, it's not a very practical algorithm because if I look at this one, if I divided the numerators, I get 3 divided by 9 over 5 divided by 10. And that's not very helpful because when I simplify that, it actually gets more complex than easy, right? So I don't bother doing it. Question number 8 says divide using multiplication. So this is the regular algorithm you're going to use to get the answers every time. So for 5/12 divided by 3/4, we know that if we change the division symbol to multiplication and use the reciprocal of the second fraction, from our experiences in section 6.1 and 6.2 with division by whole numbers and multiplication by fractions, we know that they're the same thing. So when we multiply our numerators out and we multiply our denominators out after using the multiplication of the reciprocal, I get 20 over 36, which can reduce down to 10 over 18, which can reduce down to 5 over 9, which is your answer. Now some people back here, when they rewrote it as a multiplication statement, the first thing they look for is, before I start multiplying my numerators and denominators, can I cross-reduce? And right here, 4 over 12 could have been reduced by dividing both by 4 to 1 over 3. And if I reduced it by 1 over 3, I would multiply my numerators, 5 over 1, and I would get 5. 3 times 3, and I would get 9. I would get my answer 5/9 without doing this step. I wouldn't need to do that step. Okay? So cross reduction is a very beneficial thing to make your numbers smaller and easier to reduce. The second question, if you're dealing with mixed fractions in division or multiplication, you never want to multiply or divide mixed fractions. You always want to think of them as being improper. So if I had 4.5, I would have 9/2. Divided by, if I had 1 1/4, I would really have 5/4 in total. So the red expression is the exact same value as the one above it. It's just improper instead of mixed. I'm going to keep the first fraction. I'm going to change my division to multiplication. And the reciprocal of 5 over 4 is 4 over 5. So the interesting thing, if I said on a test, what's the reciprocal of 1 1/4? The answer, the reciprocal, is 4/5. And we can't see that until we change it to an improper fraction and then flip the improper fraction. We can't flip a mixed fraction. So a wise person would take this multiplication statement now and realize that 4 over 2 could cross-reduce to 2 over 1. When you multiply your numerators out, you get 18. When you multiply your denominators, you get 5. So the answer is 3 3/5. Now, if you didn't cross reduce, you're still going to get the same answer. 9 times 4 is 36. 2 times 5 is 10. That is going to be 3 6/10, which reduces down to 3 3/5. Same answer. And your last question. 10 divided by 2 halves. Well, when you have a whole number, no matter which kind of division or multiplication question it is, you should probably always think of that as being over 1. It's much easier to visualize a whole number as a fraction if it's over 1, especially with algorithms. So 10 over 1 divided by, I can't use mixed fractions, so I'm going to use the improper fraction. Now that I have that, I'm going to keep my first fraction, which was 10 over 1, change it to multiplication, and use the reciprocal of 2.5. So there's another one. So if I say, what's the reciprocal of 2.5? The answer is 2/5. And it doesn't look like it is, but I can only look at it as improper in order to get the reciprocal. Once I have that, look for cross reduction. It's right there. 10 over 5 reduces to 2 over 1, which means when I multiply those two fractions, I get a product of 4. Now the interesting thing, if I think of this question as being an estimation question, use our division. I have $10 and I need to divide it into piles of $2.50. How many piles could you make? You can make 4 exactly, and that's why our answer is 4. Question 9 says divide, so it doesn't say which algorithm to use, but I think most of us probably use the multiplication method. So if I have 3/4 and I change it to multiplication, I use the reciprocal of the second. Multiply my numerators, I get 15. Multiply my denominators, I get 16. My answer is 15/16 for this one. For the second question, I have 5/3 divided by 17/6. I just changed the mixed fractions to improper. Keep the first fraction, change to multiplication, use the reciprocal. Check to see if you can cross reduce. I can, right here. 6 over 3 can reduce to 2 over 1. When I multiply my numerators, I get 5 times 2 over 1 times 17, or 10/17 is your answer. And the last one, I have a whole number, so I want to think of it over 1. 12 over 1 multiplied by the reciprocal of 4/3, which is that. Check for cross reduction. It exists. 12 over 3 can reduce by 3 on both sides, which is 4 over 1. Multiply your numerators, multiply your denominators, you get 16 over 1. And if you think of this question in terms of our estimation, if I have $12 and I divide it into piles of 75 cents, how many piles of 75 cents can you make for $12? The answer is 16 piles. All right, question 10 is just more of the same. So we have 13/12 divided by 5 halves, which will be thought of as 13/12 multiplied by the reciprocal. Cross reduction, absolutely. 2 over 12 would be 1 over 6. Multiply the numerators, you get 13. Multiply the denominators, you get 30. 13 over 30 is lowest terms. Keep your first fraction, change to multiplication of the reciprocal. Check for cross reduction. Yeah, bye. 2 over 1. Multiply your numerators, you get 10. Multiply your denominators, you get 11. Your answer is 10/11. For 1 3/8, change to mixed. That'll be 11/8 is the same thing as 1 3/8. Divided by 11/4, that's the same thing as 2 3/4. Keep your first fraction, change to multiplication, use the reciprocal. What a beaut. This is the best looking cross reduction question ever. 11 over 11 reduces to 1 over 1. 4 over 8 reduces to 1 over 2. When you multiply everything out, you get an answer of a half. I just realized something just now. I've already made the video for this. It's already online. Oh well, you can always have two. What's the harm in having two? In a comedy review, each performer has a quarter-hour slot. Yeah. So here is the show. Here is the whole show. And the show is 2 hours long. And each of these is made into a quarter hour. So there's 1, 2, 3, 4. That's 4 quarter hour slots. And over here, this next hour would be 4 more. So simply by reasoning it with a picture, I know that I can have 8 quarter hour shows within a 2-hour time slot. But that's not really the question. The question is, if I have 2 hours and I divide it into quarter hour time slots, the actual operation is 2 divided by a quarter. I'm going to think of 2 as being 2 over 1 multiplied by the reciprocal of a quarter, which is 4 over 1. 2 over 1 times 4 over 1 is still 8 time shows. Question 9. I'm going to draw my 15 scoops. There's my 15 scoops of flour. That's how much I have. I have 15 scoops. And each cake requires me to use 2.5. So 2.5 and 2.5, how much would that be? How many scoops is 2 cakes? 5. So I got to make them a little bit bigger, I think. So 2, this would be 5 scoops, right? 1 cake, 2 cakes. This would be 5 more cakes. This would be 3, 4, and then this would be 2 more. 5 scoops. Those are all my 5 scoops, 5 scoops, 5 scoops. That means from the picture, I know I can make 6 cakes. Each of these is 2.5, so 2.5 and 2.5 scoops is 5 scoops. Altogether, this is 15 scoops. I can make 6 cakes. But 15 scoops divided between 2.5 per would be 15 over 1 divided by 5 over 2, which is the same thing as 15 over 1 multiplied by the reciprocal. Cross reduce if you can. Yes, you can. 15 over 5 becomes 3 over 1. The product of your numerators is 6. The product of your denominators is 1. Therefore, you can make 6 cakes with 15 scoops. The hard part is this, making that statement, right? Realizing that this story problem actually boils down to 15 divided by 2.5, right? That's the connection you need to make. 3/4 of a can of apple juice. So let's draw the can of apple juice, shall we? There is the apple juice filled 3/4 full, the can of 3/4. All of this makes 6 glasses. So I'm going to cut this thing into, this is glass 1, 2, 3. Uh-oh. 4, 5, and 6. So each glass uses this much apple juice of a can. So the denominator was 4, now it's 24. And this glass number 1, took 3 parts of 24, or roughly, in lowest terms, 1/8 of a can. To fill a glass, it takes 1/8 of a can. So if 1 glass is 1/8 of a full can, how many glasses would a can of apple juice pour? 8 of them. Right, 8 glasses. Since 1/8 of a can is 1 glass, 8 glasses, if I multiply this by 8, that would be 1 can. And that's it, right?